This is my first video lesson for Unit 5C, Intramolecular Forces. Take a moment to download the class packet from my website. In this lesson, we'll be describing polar and nonpolar covalent bonds. Go to page 2 in the class packet. For the motivation, here's an analogy to help you understand polar and nonpolar covalent bonds, assuming identical animal twins who will win arm wrestling. So take a moment to analyze these pictures and then describe what is happening here. Learning target. At the end of the lesson, I'll be able to determine if a bond is polar or nonpolar by calculating electronegativity differences. The homework will be number 1, which will be a Juno part based off this lesson. Before we talk about polarity, we must first review electronegativity, which is the measure of attraction for bonding electrons only. So the values are found on table S, and the values can range from 0 to 4. So the higher the value, the stronger the attraction for bonding electrons. So from Unit 4, this was the trend of electronegativity on the periodic table. So polarity is the unequal distribution of electron density. The larger the electronegativity difference between two atoms, the more polar the bond is. In terms of polarity, there are two types of covalent bonds, nonpolar and polar. To help you understand the difference between a polar and a nonpolar bond, we're going to use a tug-of-war analogy. Each side represents an atom. The rope represents the electrons that are being shared. So this represents a covalent bond. The strength of each side is the electronegativity. If both sides have the same strength, we call that a nonpolar bond. So each side is holding the same amount of rope. So two atoms in a nonpolar bond have equal sharing of the electrons. But if both sides have unequal strength, for example, one side is much stronger than the other side, we call that a polar bond. One side has more of the rope than the other side. In a polar bond, the two atoms have unequal sharing of the electrons. The more electronegative atom will pull the electron density closer to it. In a nonpolar covalent bond, there is equal sharing of bonding electrons. The electronegativity difference is less than 0.5. Let's look at an example. Here we have a bond between two hydrogen atoms. Your first step is to look up the electronegativity value of hydrogen on the reference table. On table S, hydrogen has a 2.2 as electronegativity value. So the difference between these two hydrogens would be 0. That's why this is a nonpolar covalent bond. Let's do another one. If we look up the value of fluorine on table S, it is 4. And since each one is 4, the difference between these two will be 0. If you have a covalent bond between the same elements, it will always be nonpolar because the electronegativity difference will always be 0. Let's connect this to the motivation. How will you describe this type of sharing? So by looking at the picture, the sharing is unequal. The bear is much stronger than the penguin. So they're both forming a bond because they're both touching the ice cream cone, which represents the electron. The bear, which is stronger, has more access to the ice cream cone than the penguin does. This will be considered a polar bond. In polar covalent bonds, there is unequal sharing of the bonding electrons. The electronegativity difference between the two atoms is 0.5 to 1.7. In some textbooks, it is 0.5 to 2.0. Treat these as guidelines rather than set rules. There's always going to be exceptions. You can use either 1.7 or 2.0, and you should be fine on the regions. Let's do a couple examples. Here we have a hydrogen and fluorine bond. If you look on table S, fluorine has a 4 as electronegativity value, while hydrogen has a 2.2. So this is considered a polar bond. Since fluorine is more electronegative, the electrons will be closer to fluorine. Here we have another example. Here of oxygen and hydrogen. By looking at table S, oxygen has a 3.4 as electronegativity value, and hydrogen is 2.2. Since oxygen is more electronegative than hydrogen, the electrons will be closer to oxygen. So which bond is more polar? Is it HF or OH? So it turns out HF is more polar because the electronegativity difference in HF is greater than the electronegativity difference in OH. So the larger the electronegativity difference between the two atoms, the more polar the bond is. Let's review the guidelines again. You must calculate the electronegativity difference in order to determine if a bond is polar or nonpolar. For covalent bonding, if the difference is less than 0.5, then it's considered nonpolar. If the difference is between 0.5 to 1.7 or 2.0, it's considered polar. You can use either one. There's always going to be exceptions to guidelines. That's theme number 3. You won't see any exceptions on the exam and on the Regents, so just follow these guidelines. If the electronegativity difference is greater than 2, then there might be an ionic bond. So let's do some examples. The first step is to look up the electronegativity values of each element on table S. So for C is 2.6 and hydrogen is 2.2, the difference is 0.4. So based off the guidelines, CH is considered a nonpolar bond. In example 2, we have a CO bond. It does not matter if it's a single bond or double bond. So then you look up on table S, carbon is 2.6 and oxygen is 3.4. So the difference is 0.8, and that'll be considered a polar bond. In example 3, we have a KF bond. So we know K is a metal and F is a non-metal. So we're expecting an ionic bond here. So K, if you look on table S, is 0.8, F is 4.0, so the difference is 3.2. Since 3.2 is greater than 2, this is an ionic bond. Let's do a learning check. Which combination of atoms can form a polar covalent bond? Pause the video and resume once you complete it. So the answer is choice 2. So 1 and 3 are wrong because they're the same elements. It's always going to be nonpolar. And number 4 is an ionic bond because it's metal and non-metal. Learning check number 2. Which bond is the least polar? Pause the video and resume once you complete it. So you gotta use table S and calculate the difference, and the answer is choice 4, NCl. Here's a nice diagram to help you identify if a bond is gonna be nonpolar, polar, or ionic. The more polar your bond is, the higher the electronegativity difference between the two atoms in the bond, and the bond has increasing ionic character. In the opposite case scenario, the less polar your bond is, the smaller the electronegativity difference, and the more covalent character your bond has. In some textbooks or scientific literature, an ionic bond is a completely polar bond. The reason for that is because the electronegativity difference is so large that one atom actually takes an electron from another. But keep in mind, the terms polar and nonpolar are usually applied to covalent bonds. That is where the polarity is not complete. On the Regents exam, if there's a question that asks which of the following has the most or more ionic character, you have to calculate the highest electronegativity difference of those bonds. It is usually the ionic compound. Learning check number 3. Which substance contains a bond with the greatest ionic character? Pause the video and resume once you complete it. You have to calculate the greatest electronegativity difference in the bonds, but typically for Regents questions, it's usually the ionic compound. So it's choice 1. Learning check number 4. Which substance contains nonpolar covalent bonds? Pause the video and resume once completed. For nonpolar covalent bonds, the electronegativity difference must be less than 0.5. If we look at choice 1, it's between the same elements, therefore electronegativity difference is 0. So the answer is choice 1. So take a moment to do table 1 and table 2, pause the video, and resume once completed. So here are the answers. For check of understanding number 1, which bond has the most ionic character, most covalent character? From the table, NaCl has the greatest electronegativity difference, therefore it has the most ionic character. The most covalent character are the ones with the 0 as electronegativity difference, so there's many possible answers. Here are the answers to the second part of the table. Check of understanding number 2. Which bond has the least ionic character, the least covalent character? By least ionic character, it means that's the most covalent character. So you're looking for one with the smallest electronegativity difference. So from the table, there's many possible answers. For the least covalent character, you're looking for the most ionic character. So which one has the greatest electronegativity difference? That would be Kn. Now we're going to talk about partial charges, which indicates if an atom has a weak positive or a weak negative charge. So less than 1, it's only for polar bonds. It is to indicate which atom in that polar bond is less electronegative or more electronegative. The partial positive charge is used to indicate the lower electronegative atom. The partial negative is to indicate the higher electronegative atom. This is how you draw the partial charge symbol. Just follow the circle. Here we have a HF bond, which is a polar covalent bond. Hydrogen has the lower electronegativity, so we indicate that using a partial positive charge. Since F has the higher electronegativity, we indicate that with a partial negative charge. Notice there's two poles here, one positive and one negative. We call this a dipole, which is present only in polar bonds. A dipole is a separation of positive and negative charges in a molecule. So HF, since F is more electronegative than hydrogen, electron density will be more concentrated in fluorine than hydrogen. We can draw a dipole moment arrow, which indicates the direction of where the electron density is located. In the back of the arrow, it looks like a plus sign, which indicates the atom with the lower electronegativity. The bigger the arrow, the greater the electronegativity difference. The smaller the arrow, the smaller the electronegativity difference. Here we have a nonpolar, polar, and ionic bond. Nonpolar bonds do not have a dipole or partial charges. Polar bonds have a dipole and partial charges. Ionic bonds have a full charge. Just to summarize, HF is a polar bond because the electronegativity difference is greater than 0.5. Fluorine, which is more electronegative than hydrogen, has a partial negative charge, and hydrogen has a partial positive charge. The electron density will be closer to fluorine. For a hydrogen-hydrogen bond, this is nonpolar because they're the same element and the electronegativity difference is 0. For the OH bond, it is a polar bond because the electronegativity difference is greater than 0.5. Since oxygen is more electronegative than hydrogen, electron density will be closer to oxygen, therefore it has a partial negative charge. Hydrogen will have a partial positive charge. For lithium and fluorine, fluorine is much more electronegative than lithium, so it will take the electron, forming an ionic bond. Just to review, the larger the difference in electronegativity, the larger the dipole moment. HF is more polar than OH because electronegativity difference of HF is greater than OH. As a result, when we draw the dipole moment arrow, the one for HF is bigger than OH. This is a review slide summarizing the nonpolar, polar, and ionic bond using the analogy of a tug-of-war. So this concludes the video lesson for today. Remember to do the Junipod homework.